Hello everyone. Today we are going to discuss the second preparative method of colloid. Okay, it is peptidation. Now, what is peptidation? The process of converting a freshly prepared precipitate into a colloid by adding small amount of electrolyte. Now, see. Let us take an example. Okay, let us take an example when ferrous hydroxide, okay, iron hydroxide, it is 3. When FeO3, FeOH whole 3 is prepared, it is a freshly prepared precipitate. Okay, it is freshly prepared precipitate. Suppose now how it is prepared? When FeCl3 react with 3 moles of water, it produces this one, freshly prepared iron hydroxide. Now, when it reacts with small amount of electrolyte, suppose FeCl3, it is a electrolyte. Electrolyte, it produces colloidal solutions, which is in red blood, red, brown colored colloidal solutions we observe. Now, how? See, the colloidal solution is made up of this one only, FeOH whole 3. FeOH, suppose whole 3, this one I have taken colloid. This colloid is stable with the help of this Fe3 positive ion. That's why here is positive ion is surrounded the colloidal particle. Now see, here is the main concept here. This one is PPT. That means which is settled down in a test tube. Suppose this one is a test tube in which the reaction is going on. Here is a solution. But in the lower portion, suppose it is the main PPT. It is the suppose FeOH whole 3 settled down in the lower portion of a test tube. This is a PPT, not colloidal solution. Okay. Now PPT is settled down in the lower portion of any container after the reactions. When this PPT is reacted with ferric chloride, that means FeCl3, it produces colloidal solutions. Now colloidal solutions is a homogeneous mixture, as you know. It is, suppose this is a beaker. Colloidal means it is homogeneously mixed with the dispersion phase and the dispersion medium. Okay. Then this FeOH whole 3, this PPT, that means here it is PPT, it's surrounded with some positive ions comes from this FeCl3. These positive ions are just stabilize the colloid. Okay. What it means? What does it mean? जब colloid यहाँ पे था, ये नीचे precipitate की तरह पड़ा हुआ था, लेकिन जब यहाँ पे आ गया, क्या हुआ, ये जो colloid का जो पार्टिकल है FeOH, इसके चारों तरफ पॉजिटिव चार्ज से घिरा हुआ है, इसीलिए ये नीचे में सेटल डाउन नहीं होके ये पूरा मीडियम में, दैट मीन्स पूरा डिस्पर्शन मीडियम में डिस्पर्स्ड हुआ है, इसलिए ये कॉलोइड है, लेकिन ये प्रेसिपिटेट है. ओके, क्लियर नो? Okay. And the last preparative method is the Bragg's arc method. Now see what it is. It is Bragg's arc method. Third number. Not Bragg's arc method. It is arc means electrical spark. Okay, arc means electrical spark. Now see, this process involve dispersion. Okay, dispersion as well as condensation. How? See, let us take a ice bath. Okay, this one is ice bath in where these are ice. These are ice. It is ice bath. Okay, it is ice bath. But in between the ice bath, here is a water solution, or you can say water, which is a dispersion medium. Dispersion medium. When we apply electrical spark, that means this is a electrode, this is a another electron. Suppose it is positive, suppose it is negative. When we apply electrical spark in here, the vaporization, okay, vaporization of this metal takes place. Vaporization, these are electrode. This electrode is mainly made up of gold, silver, platinum, etc. The vaporized, these metals ions come this way. Suppose this is the vapor. But due to the presence of this ice bath, which again condenses this vapor metals into the dispersion medium and forms the colloidal solutions. Okay. Main thing is, due to this ice bath, this vapor metals again condenses to this dispersion medium to produce colloidal solutions. That's why it is known as dispersion, that means this one, and condensation, that means with the help of ice bath. Okay. Now, the next topic is the purification of colloidal solutions. That means purification means the process used to reduce the amount of impurities in the colloidal solutions is known as the purification of colloidal solutions. Okay. Now, so the first process for the purification of colloidal solution is the dialysis. Dialysis is the process of removing a dissolved substances, that means impurities, from the colloidal solutions by mass of diffusion through a suitable membrane, and the apparatus is known as dialyzer. This one. Substance means here is impurities from the colloidal solutions by mass of diffusion through a suitable membrane. That means there will be a membrane, that means a layer, or you can say a paper, or you can say any substances from where only the impurities component can pass, but not the colloidal solution or colloidal particle. Okay. Now see diagrammatically how. Now see, here is the diagram of dialysis. Okay, by which we can purify the colloidal solutions. Now see how. Let us take a container in which in the lower portions water is entering, here is water is removing. That means this entering and removing of water is continuously going on. Now here is a special type of membrane, that means a layer. Special type of membrane by which only the crystalloid, that means impurity can pass, not the colloidal particles, because colloidal particles are little bit larger in size than the impurity. That's why when we continuously pass the water, the crystalloid, that means the impurity particles, comes out from the dialyzing membrane and removes with the water. In this way, we can purify the colloidal solutions. Now, This process is very slow. This process is very slow. That's why another process is introduced, which is known as electrodialysis. Okay, electrodialysis. Another process introduced, which is known as electrodialysis. This one is the diagram of dialysis. Okay. Now, if we use electrodialysis, that means electricity. To provide electricity, we need an electrode. Here is an electrode, here is another electrode. Suppose it is taken as, here is anode. Here is anode. That means suppose here is positive charge. Okay, positive charge. This is cathode, here is suppose negative charge. Now, since the colloidal particle and the crystalloid has a charge, that's why the opposite charge, suppose the negative charge will move this way and the positive charge will move this way. And again, the water is moving continuously, no? That's why when the electricity is provided, then the charged particle of the crystalloid, that means impurity, is attracted towards the opposite charged electrode, and by the flow of water, the impurity comes out from the container. In this way, with the help of electrodialysis, we can purify the colloid solutions. Okay, this one is the diagram of electrodialysis, not simple dialysis. Simple dialysis, there is no electrode or there is no electricity. Okay, now see the next purification is the ultrafiltration. Okay, ultrafiltration is the process of purification of colloidal solution. Is based on the pore size of the any filter paper. Okay, this pore size should be much as smaller to pass only the impurities, not the colloidal solution itself. Okay, but see, the pore size of ordinary filter paper are too large. That's why it cannot be used to filter our colloidal solutions. Now, if the pore size of the filter paper is so much big or so much large, then obviously we have to remove the pore size. No, to remove the pore size, we are using here is colloid. This colloid is 4% nitrocellulose solutions in the alcohol and water. When we add this solution, that means 4% nitrocellulose in water and alcohol in the filter paper, the pore size of the filter paper will get reduced. And that filter paper is called the ultra filter paper, by which only the impurity or the crystalloid particles can pass, and this way we can purify the colloidal solutions with the help of ultra filter paper, and the process is known as ultrafiltration. Okay, now the next topic is the properties of colloidal solutions. Now we are going to discuss some properties of colloidal solutions. First property is the optical property. And the property is known as Tyndall effect. Okay, now what is Tyndall effect? When a strong beam of light pass through a colloidal solutions in the dark place, then the path of the beam get eliminated. And the process is known as the Tyndall effect. Now see experimentally what happens when a light, suppose light with a high beam is passing through a colloidal solution of milk. That means a simple milk solution. Okay, then suppose this is the light. Light is going in this way. The light, after striking the milk, that means dispersed phase or the colloidal particle, the path in which the light is approaching towards the colloidal particle is eliminated. That means in the portion in which the milk solution is there, we cannot observe any light. That means this happens due to the scattering of light. Okay, and this process is explained by the Tyndall effect. Now, it has two conditions. First condition is the diameter of the dispersed particle is not much smaller than the wavelength of the light. Since it is light, no, that means it have some wavelength. The diameter of the dispersed phase is not so much smaller than the wavelength of the light. This is the first condition. The second condition is the refractive indices of the dispersed phase and dispersion medium differs greatly in magnitude. That means there is so much of difference between the refractive indices of dispersed phase and dispersion medium in magnitude. That means it may be positive or it may be negative.